What up nerds, my name's Colin Mrs. Swirly Eyes Keefe, and today we're going to build the Bluetooth RC car vehicle schematic and board. Start by opening up Eagle. Alright, file, new schematic. Let's turn on the grid and let's immediately make the board. Create from schematic, yes. The only thing we're going to do here is change the grid. So we'll do grid millimeter 1, grid alt millimeter 0.5. Cool. And we'll be back to this very shortly. So let's go back to the schematic and save. Call it whatever you'd like. I'm going to call it Bluetooth RC car vehicle. And we're ready to get started now. So the Bluetooth RC car vehicle board is a little more complicated than the remote. There's a lot more going on, more connections. We have to be a little more careful about how we go about things. But we're going to start very similarly. We're going to do one piece at a time, and we'll go over each piece in this and what we need to do to make a fully functioning board. Alright, so let's get started. Add our microcontroller. So I'm already familiar that we're going to add the Atmega. So we're going to add the Atmega 328P. Careful, there are a couple variations. The one we're going to be doing is this one right here. It shows 2 right now, but it'll be removed by the time you guys get there. So we're going to do this one. It's a 32 pin board. A little bit different if you're familiar with the actual Arduino Uno, which has a Atmega 328P microcontroller, but has a dual inline package. This one is a surface mount. It's a large symbol, but drop it anywhere you like. Now there are several connections on here, and we're going to go ahead and make all of them now, and we'll show what gets connected to it later. So let's start with power. So we have a reset pin, and it's going to be connected to a 10K resistor, 0805 surface mount, and let's give it a label. The style I like to use is 0.05 ratio 10 font vector, and the XREF font. We'll name it soon. And we're going to have our VCCs tied together. The multiple ones here are just denoting that on the actual chip there's more than one VCC pin. And we're going to have several capacitors tied onto these that will connect. So we're going to have several capacitors connected to the VCC. These are all recommended by the data sheet, and they are 0.1 microfarad. Everything we're doing is 0805 package. And since there are 3 pins, we have 3 capacitors. These are all going to be connected to ground, and of course connected to VCC here. Observe, we also connected a VCC. A VCC is just the analog on the chip. And we're going to be powering this with 5 volts. We will provide the actual 5 volt power supply later. Let's name this pin reset, and similarly this is going to be 5 volts as well on the reset. Pull up resistor, make sure that unless we're actuating the reset pin, writing a load to it, that it'll always be tied to 5 volts or high. So the reset pin will always be high unless we send a low signal to it. Next we can add the grounds, and for the crystal, this guy right here, crystals, oscillators and resonators. And this crystal from the data sheet needs 2 12 picofarad capacitors. And these 2 12 picofarad capacitors are connected to ground. Alright, so that's going to do us for power, ground, and this is the external oscillator that we need for our microcontroller so that you can keep the clock. Next, on pin 9, we have our servo connection. On pins 15, 16, and 17, we have our SPI interface. They are MOSI, MISO, and serial clock. We need to communicate via the Bluetooth, so we need to use the RX and TX pins. Notice here, explicit RX and TX pins, the Arduino Uno, or in this case the Atmega 328, do have a dedicated hardware UART, so we're actually able to use the RX and TX pins. And per my convention, I like to name on the microcontroller it RX and TX respectively. And then on the Bluetooth, we will flip them as appropriate. Finally, our last 2 pins are here, phase and enable. And let's name them appropriately. Alright, and because I like to do this, keeps it nice and organized, let's put a box around this. So we'll do wire, info layer, and I like to be short dash. And let's give it a label. We'll call it Atmega 328P. And I like it to be size 02, I believe, ratio 20, and I try and put it in the center the best I can. Cool. Alright, so now let's add our Bluetooth. So add same Bluetooth as before when we did the remote. We want this one, however, to be vertical. So we want it to stand up. We're not going to need it to hang out the side like we've done the remote. Everything else should be the same. And name TX RX and name RX TX here. So just make sure that these are opposite, so that TX on the microcontroller goes to RX on the Bluetooth, and that TX on the Bluetooth goes to the RX pin of the microcontroller. You gotta power this guy, so we'll do it with 5 volts, and of course, ground. Box it. And let's label it Bluetooth. Cool. Alright, so next, to program AVR microcontrollers like the ATtiny and the Atmega, we need to set the fuses as we explained in the ATtiny tutorial. To do that, we need to bootload it, and what we do is we use an AVR ISP. So we pretty much configure the Arduino, or we use another device that can act as an in-system programmer to bootload our chip and set all the fuses. So you can type in add AVR, and we should have it right there, vertical, male, through hole. You can just break this guy out, so a bunch of nets. Again, we don't connect VCC, and we will rely on make sure we power the device to program it externally. Name Miso, name serial clock, name reset. So this will connect to the reset up here. So pretty much reset will always be held high unless when we're doing the in-system programmer to program the chip, it takes it low and resets the device. Give it a label, call it AVR ISP. Place it in a nice corner. Next, we need to add the FTDI programmer. When you program the Arduino Uno, usually you plug in the USB A to B, I believe, cable, and you upload your program, and you don't even think about it. Well, there's a special chip on board that actually uses the RxTX, the serial pins, to actually program the chip. So it's a little bit different from bootloading, which is what we use for the AVR ISP. And in many cases, is that you can use the AVR ISP to actually program the chip. So that's what we do with the AT25. For the Atmega 328, we could probably do the same. However, it's more common and easier to program it using RxTX, so we can use our USB port and have a very simple and easy to use cable. But to do that on our board, we didn't put on this particular chip that will actually act as a means by which we can program the chip. So we need a special header and actually a special piece of hardware to be able to program it, and that is why we need this FTDI programmer. If we do add FTDI, which is here, if you study closely, we have several pins and we're only using a handful of them. So let's make our connections. Again, we don't connect power. It'll be up to us to power the device. And there's this special pin called DTR, which needs a 0.1 microfarad cap, which connects to reset as well. And what this DTR pin does is that when we program the device, and this happens with the Arduino as well, that we need to reset the Atmega or any other microcontroller in general. And this DTR allows it to be programmed via software. And what I mean by that is while you're doing the programming, it knows when to reset. We don't have to do it manually. And of course, we need our RxTX because that's how we're going to program it. And once again, they will be flipped such that they're talking to the appropriate channels. So again, TX on the FTDI goes to RX of the microcontroller, and TX of the microcontroller goes into the RX of our FTDI. And that's it for that guy. So let's box it up and label it, call it FTDI programmer. So we have made most of the connections, pretty much all the communications going down. Again, the FTDI and the AVR ISP are going to be used to program the Atmega and our Bluetooth RC car. And the Bluetooth is what we're going to be using to do our wireless communication. Alright, so we are pretty much halfway done, but the more complicated circuitry is coming up.